Hey everybody, this is lesson 2, solving equations for algebra. We actually spent 2 days working on this in class, but I'm going to record the whole video right now, start to finish, for the entire lesson packet. So if you were here for one day but missed the second day, or if you were here for the second day but missed the first day, you may have to do some fast forwarding or rewinding or whatever to get to the part that you need. But this is 2 days worth of teaching time. So just know that if you've already got part of this done but just need the rest, just fast forward till you get there. So the purpose of this lesson is to be able to solve equations with one variable, and we're going to look at a lot of different types of equations. If you were in Foundations, you did this with me last semester, but we did it in like 4 or 5 different lessons. So we're going to do this all in one lesson kind of as a review. So solve equations with one variable, including those with variables on one or both sides. And then I'm also going to show you how to tell how many solutions an equation has. So we should be able to do all of that by the end. Again, most of this is review. Or really all of this is review. But if you're struggling with some of it, just kind of watch closely at the examples as we work them. All right. So if you remember, the whole purpose of solving an equation is to figure out the value of the variable. So the variable is the letter in there. And so in order to do that, we have to find a way to get the variable by itself. The mathy word for that is we find a way to isolate the variable. So to do that, to isolate the variable, get the variable by itself, we use inverse operations. And what that means is that, sorry y'all, I don't write great on my iPad, so we just kind of work with it. Anyway, that means that if we're adding to get the addition to cancel out, we do subtraction. If we're multiplying to get multiplication to cancel out, we do division. So don't write this down, but just remember that. Like if you had something like 2x plus 4 equaled 12, you would do inverse operations to get the x by itself by subtracting the 4, that's the opposite of addition, and then dividing by 2, because that would be the opposite of the multiplication that's happening there. So when we talk about inverses, that's what we're talking about doing. So when you solve equations, mathematically speaking, what just happened? Done. I think this is still recording, but I don't really know what just popped up, so there's that. Okay. Mathematically speaking, it doesn't really matter which side of the equation you put your variable on, but because it makes it easier for us when we do inequalities to have the variable on the left, we're going to practice solving them by putting our letter on the left here too. Sorry. Variable, can't really read what that says. All right, so again, this is all review. Here are the steps to solving these things. First thing you do, and this is a Miss Ware step, not a legitimate mathy step. So if you're ever reading a problem and it says, what is the first step to solving this? You're never going to say what we're about to look at here. But no joke, it's beneficial to do this first step because it gives you just kind of some boundaries so you kind of know where to go and what to do next. So I call the first step splitting the world, but we draw a line through the equal sign so that you can separate your equation into 2 separate sides. I changed to a different stylus. I'm way better with this one. So do that, and then you have 2 separate sides of your equation. You look at each side separately to do step 2. So in step 2, you simplify each of those expressions using distributive property. So this is the same steps we used to simplify from lesson 1. Or combining like terms. Then, once you've got it fully simplified, so if it's fully simplified, you'll be down to 1 or 2 terms on each side. One could have an x and one not. If you've got more than 2 terms, you've not simplified it all the way. But once you get it fully simplified, then you're going to use your inverse operations to solve. to isolate the variable. All right, outside of being able to solve equations using these steps, you also have to be able to tell how many solutions your equations are going to have. And so if you remember from when we've done this before, or when you did this in 8th grade, you learned that there are 3 basic type solutions that equations can have. And so to figure that out, you've got to fully simplify your equation. You really could work it all the way out to the end and see this. But if you don't do that, there is a place after step 2 that you can look at it and be able to tell how many solutions it's going to have. So if you reach step 2 and you have simplified each of those expressions, then you can look at what you have left and see how many solutions your equation is going to have. Now, once you've got it fully simplified, you should end up with an mx and a b on both sides. So you'll have an x term and a non-x term on one side, and an x term and a non-x term on the other. So I call that mx and b because when we do linear equations later, it makes sense. So you'll know that there's going to be a solution. There'll be one solution to an equation if your mx and your b, or if your mx is different on both sides. And your b can be anything. But if the x's are different, then you know that there's a solution to that and you can continue to solve it. So what that looks like is if you end up with an equation that's like 2x plus 3 equals 3x plus 4, as long as the x parts of that are different, so the 2x and the 3x are different, then you automatically know that there's one solution. Now the answer to that, if you keep working it out, is going to look like x equals a number. And that's how you know you've got a solution to that. Now, if you reach that second step and you've simplified everything to an mx and a b, and your b's or your mx's are the same, then you're going to either have no solution or an infinite number of solutions. And so you've got to look at the b to be able to tell whether you're going to have none or infinite. And if you remember, an equation's whole purpose is to show you two things that are equal to each other. So something that's never going to be equal is going to be what has no solution. So that means if you had something like 2x plus 3, and then on the other side you had 2x, the only way to create something that will never be equal to what's on the left side, on the right side, would be to put something in place of b that is not a 3. If I put a 3 in there, they're going to be the same. But if I put anything else, they're not going to be the same. So the rule for this is to have no solution. You have to have the same x, but a different b. Doesn't matter what the b is, but it has to be different in order to have no solution. So same x, but a different b value. Ooh, that was not what I wanted. Just kidding. Same, different. And then to be infinite, you got to have the same of both. Because if you have a 2x plus 3 on this side, the only thing that would be the same would be to have 2x plus 3 on this side. And so everything has to be the same. Same x, same b. Now, if you happen to not notice that, and I find that a lot of my students forget to look for that kind of thing, and they just keep on working it out, and they get to the end and they're like, I don't know what my answer actually is here, because strange things happen on these that have no solution or infinitely many solutions. But to have no solution, your final answer is going to end up looking like 0x equals some number. And that would be an indicator that there's no solution, because it creates a false statement. 0 never equals a number, so you know that that's not true. And so that's going to be a no solution situation. If you end up with 0x equals 0, well, that's your situation where you have an infinite number of solutions, because 0x always equals 0, because everything times 0 is 0. So that statement is always true, and that's what it would look like for infinite. So like you get something like 0 equals 1, 0 equals -5, that's going to be no solution. But 0 equals 0 is infinite. So you can see it after step 2, or you can finish working it to the end and get one of those types of solutions over here. And either one of those will be able to tell you whether you've got none or infinite. So if you run into that situation. Now, if you decide that there is one solution, like you look at that equation after step 2 and you're like, okay, yeah, there's going to be a solution to this. Well, you can't just stop and say one solution. You have to actually finish working it. So if there is one solution, you have to continue to solve to get that value. So the whole purpose of this is not just finding the number of solutions. It's about finding the actual answer to the problem afterward. All right, let's get into some examples of this. So here we have examples of some equations that have variables on one side, and then we're going to have some equations that have variables on both sides. And we're really going to look at both of those things separately in these notes here so that you can kind of get the hang of one and then move on and get the hang of the other. But if you look at this first one, we've got some stuff going on the left side. So I'm going to draw my line to divide this into 2 separate parts. We'll zoom out a little bit on that like that. And then I'm going to look at each side and try to simplify them. Now, when you look at the left side, we got a whole lot of stuff going on over here. On the right side, all it is negative 72. So there's not going to be anything to simplify on this side, but there is stuff that needs to be simplified over here. So when I look at this, I'm going to look for distributive property and like terms, and that's going to be the things I can do to simplify. Now, this one doesn't have distributive property because there's no parentheses. So I'm going to just look for like terms and put those together. So 6x is going to be alike with 3x. And then 31 is going to be alike with negative 4. So I'm going to add those things together. 6 plus 3x makes 9x. 31 plus negative 4 makes positive 27. And I'm going to bring down negative 72. So from there, I've got to start working on PEMDAS in reverse. And so I look at what's with my x over here. I've got a 9 attached to it and a 27. And I want to use inverse operations. And we always move whatever's not attached directly to the variable first. So I'm going to move the 27 before I move the 9. 27 is being added, so the inverse of that is subtraction. So I'm going to subtract 27 off of both sides. That cancels out over here, and my 9x comes down. Negative 72 minus 27, or negative 72 plus negative 27, however you want to read that, combines to make negative 99. And then we can finish this with division by 9. So, and we divide because 9x means 9 times x, and so we divide by 9 to cancel multiplication. And negative 99 divided by 9 is negative 11. All right, go on to the next one. Same thing, I'm going to draw a line. Notice that the left side on this one is not simplified, but the right side already is. So I'm going to simplify this first. I do have parentheses this time, so I'm going to need to do distributive property. So 2 times x and 2 times 3 gives me 2x plus 6. This is negative 14 still. And so that's fully simplified. Now I'm going to start moving stuff. So I want to move the 6 first because it's not attached directly to the x side by side. So I'm going to subtract the 6 because 6, positive 6, negative 6 are opposites. So I'll subtract 6 over here. Negative 14 minus 6 is negative 20. The 2x comes down. Now divide both sides by 2. So x will be negative 10. All right, let's do a few more. All right, take a look at this next one. Kind of the same thing. So if I'm going to work this one out, I've got a couple of things going on over here. So I've got some distributive property and I've got some like terms both on this left side because I've got these parentheses right here and then I've got this over here. So anytime you've got both, you always do distributive property first because PEMDAS would tell us we have to do with our multiplication with our parentheses before we start adding and subtracting things together. So I'm going to start with this 1/2. I'm going to multiply 1/2 times 4 and a half times 2. So 1/2 times 4x will give me 2x. A half times 2 is positive 1. And then I haven't used my negative 3x yet, so I'm going to bring it down. From here, I'm going to combine terms. So my 2x combines with my negative 3x. And I end up with negative 1x. And then that positive 1 just comes down. Bring down the 28 on the other side. Now we've got something that we're ready to solve. So I'm going to start by moving what's not attached to the x first. So moving the plus 1. Subtract it to cancel it. And so that's going to give me 27 on this side. And my negative 1x comes down. And then to cancel that negative 1 attached to my x, I'm going to divide by negative 1. So my x will equal negative 27. All right, we're going to look at one more together, and then I'm going to let y'all pause the video and try a couple. And then we'll come back and check them, and then we'll move into some that have variables on both sides. So at this last one, and the reason I gave us this one is because it's set up in a different order. So if you notice, there's nothing to simplify here. The 3.6 and the negative 2.4m can't go together. They're not alike. But my 3.6 is in the front this time. So we still got to move it first because it's not attached directly to the m. But we're going to move it by subtracting it. Even though there's subtraction right here in the problem, that minus is attached to the 2.4. So it's going to get treated like a negative 2.4 right here. The 3.6 that's right here is positive. So the only way to get rid of that positive 3.6 would be to subtract it from the problem. So 3.6 minus 3.6 becomes 0. So I'm going to subtract 3.6 over here. And so my negative 2.4m comes down. 12 minus 3.6 is going to give me 8.4. And so now my final step is just to divide by my negative 2.4. And that's going to give me a really weird answer, and that's okay. Not all of these come out to be nice and pretty. Oh, this one's not really weird. This is just a little bit weird. But they don't have to be whole number answers. You can get decimal answers, and that's totally okay. So 2.4 or 8.4 divided by negative 2.4 is negative 3.5. If you ever do get a really weird answer, like not a pretty decimal like that, you just give it as a fraction instead, and that way you won't have rounded your answer. Your answer will still be correct. So, all right, moving on. Okay, take a minute and pause the video right here, and I want you to try these next two on this slide so that we can see if you're able to do this on your own independently. So pause the video, try these, and then unpause it and come back and see if you were correct in what you got. And then we'll move into some that have variables on both sides. If you didn't pause the video and you're still watching, pause the video. Try them on your own. Okay, so take a look at this and see if you got the same answers that I got. And if you didn't, pause the video again and go back through my work compared with yours and see if you can see where your mistake was. But you should have gotten negative 6 for the first one, and then the second one comes out to be 4.3 repeating, or you can leave it as a fraction, 13 over 3. What you can't do is just put 4.3 and leave it at that. You've got to have the repeating bar, or you've got to have the fraction form of it. Because if you put it at just 4.3, you've rounded it, and your answer would be wrong. All right, so we're going to move on into some now that have variables on both sides. So here we've got equations that have variables on both sides. The steps are really still the same. A lot of people actually like this a little bit better. But these are going to be the ones that could potentially have no solution or an infinite number of solutions. So we're going to have to kind of add ourselves a moment to check for that as we work through these. But we still have to start by simplifying, so we're going to start out with drawing our line and simplifying both sides. So on this one, when I go to simplify both sides, I see parentheses on both, so I'm going to have to do distributive property on each one. And so 6 times 5 is 30x. 6 times negative 3 is negative 18. A third times 4 is 8x. A third times 12 is 4. Now, this would be the point where you can check and see if you're going to be able to get a solution or not. And the way that we check that is we look to see if our x's are the same or different. If our x's are different, we can continue working. If our x's were the same, we would have no solution or infinite solutions, and we would look for that at that moment. But since our x's are different, we're going to keep working this one just like we normally would. So when you have variables on both sides, your goal needs to be to find a way to get all of your letters to the left side and all of your numbers to the right. So if I look at what's on the left side now, I have 30x and I have negative 18. This negative 18 doesn't need to be here because it doesn't have a letter with it, and I only want things with letters on this side. So I've got to find a way to move this over to this side. And then on this side, I've got this 8x that doesn't need to be on this side, on the right, because it's got a letter with it. So I've got to find a way to move it to this side. And we move those terms just by adding or subtracting them. So if 18 is being subtracted over here, I'm going to add 18 to cancel it. And what I do on this side, I also have to come over here and do on this side. I'm going to add the 18 under the 4 because they're going to be like terms. At the same time, I'm going to take that 8x that I don't want over here and subtract it because 8x minus 8x would cancel. So if I subtract 8x over here, I'm going to subtract 8x over here. And so when I finish simplifying this, I should end up with a one-step equation. So 30 minus 8x is 22x. 4 plus 18 is 22. And so all I have left now is to divide, my 2 looked weird, both sides by 22. Because I need to get the 22 off of this x. So divide it on this side, divide on this side. So 22 divided by 22, I accidentally paused it, sorry. 22 divided by 22 gives me 1x. 22 divided by 22 on this side gives me 1. So my x is 1. So always look for that. Now, if you didn't have me last semester, you're probably not used to seeing this set up just like this, where they cancel something on both sides. I think Ms. Chancellor made you move the x first, then move the number in 2 separate steps, and then get around to finding your answer. I really like the way it looks to do it at the same time. So I take my x and move it over here. I take my number and move it over here. And that way I'm seeing something canceled on both sides at once. And so it kind of keeps it balanced and looking nice. And then you end up with that little one-step equation at the end and you're done. So that may be a little bit new for you folks that had Ms. Chancellor last year. But it's really the same thing. It's just in a different order. Let's take a look at this next one. So the left side, 5x plus 5, is already simple. X and 5 can't go together, so that's going to be stuck like that. But the right side's got some distributive property in it because we've got these parentheses. So that's going to become 15x and negative 12. I'm going to bring down my 5x plus 5. Sorry, I skipped slides for a second. 5x plus 5, like that. Now, again, this is a good place to look and see if you're going to have a solution or not. So I have different x's. That means there is a solution. So I'm going to keep working this. So I want my letters on the left. So this plus 5 that's right here needs to go. If I subtract 5 from here, I'm going to subtract it from here. And my 15x that's on the right side needs to go over to the left side because it has an x with it. So I can subtract it. 15 minus 15 cancels. So I have to subtract it on this side too. So 5 minus 15x will give me negative 10x. Negative 12 minus 5 is negative 17. And then we'll divide on both sides by negative 10. And that allows me to get x by itself. Negative 17 divided by negative 10 is positive 1.7. So really simple. Hopefully this is mostly review for a lot of y'all. Oops. All right, let's do a couple more together and then let y'all try a few. So this one we've got parentheses on both sides, so we'll distribute. And then same deal. I've got to get my x's to one side and my numbers to the other. So I'm going to add the 7. Now notice this. The numbers on the right side are in the wrong order, or in a different order than what we're used to. The 7 that I'm adding right here gets added to the 6 because they would be like terms. The negative 2x has to get added to cancel because I need my letters on this side. Fighting with my stylus, y'all. Hang on. Plus 2x. Sorry. Okay, so I end up with 9x. And negative 6 plus 7 is 1. And then I'm going to divide both sides by 9. Now, when I did this in class yesterday, or day before yesterday maybe, some people did the division on this, and they got 9. But 1 divided by 9 is not 9. 1 divided by 9 is 1/9. So be careful with that and make sure that you're doing that division carefully. So leave it at 1/9. You also could put 0.1 repeating. That would be acceptable because 1/9 is 0.1 repeating. All right, we'll do one more together, and then we'll go from there. I forgot to say let's look at it at this point to see how many solutions it had, but notice that the x's were different, so it had a solution. That's why we were able to keep working it. Try to get in the habit of looking for that so you don't have to work it all the way out only to find that you couldn't have gotten a solution anyway. So the next one, we've got extra stuff going on this left side. We've got some distributive property, and we've got some numbers outside of the parentheses, so we'll have to combine some terms. So let's work on simplifying that first. So I'm going to multiply 3 times 2x and 3 times negative 1. My negative 7 that I haven't used yet is going to come down. And then I'm going to combine terms here. So I've got a negative 3 with a negative 7. So that's going to combine to make negative 10. So I have 6x and negative 10. And I'm going to bring down this side. Now notice that what I have here is exactly the same on both sides. 6x, negative 10. So because everything here is exactly the same, this is a problem that I know has infinitely many solutions. You also could show that using an infinity symbol. Sometimes that's also called all real numbers. Lots of ways to look at it. All right. So I'd like you to take a second. Try these 2 on this slide and the 2 on the next slide. Yes, you're going to try these 2 and the next 2. And then come back to the video and see if you were correct in those 4 questions. Again, look for whether they're even going to have a solution or not before you continue working through them. Because sometimes you'll get a situation of no solution or a situation of infinite solutions, and you don't have to keep working it at that point. So pause the video, try those, and then come back and see if you were correct in all 4 of them. All right, so take a look at the answers to these 2. Hopefully you got no solution for that first one. And the second one comes out to be a really weird decimal, so it needed to say a fraction at 34 over 13. Now, if you were at home working those with a calculator and did not have like a TI-84 that could do the fraction part for you and use Desmos, you might have got a decimal for this. And the decimal was like 2.615, crazy stuff. Fine if you wrote that down, but if you were doing this in the classroom, you'd want to be able to put it in fractional form. So 34 over 13 would be a better choice. This one's no solution, and some people may have had a hard time seeing that, but your x's end up being the same, 2x and 2x. There's a b on this side, but there wasn't one over here. So I put a 0 in that spot so I'd have something to compare to. But 0 is not the same as negative 6. And so since you had the same x but a different b, this was a no solution problem. If you kept working it, you reached the point of having 0x equals negative 6. And that also would be no solution because 0 does not equal negative 6. All right, let's look at the next 2. take a look at these and see if you got those right as well. So this one was pretty straightforward. You combine terms and then worked it out and you get negative 19. And then this one on the right side, you had to do distributive property and combine terms, and you get 5x minus 11, where we already had 5x minus 11 on the other side. So this is infinitely many solutions on that one too. Okay, that is the end of the stuff from the first day that we did equations. So this would have been from, I'm trying to think what day we started this. This would have been from the end of the day, Monday, I think. Nope, probably would have been Tuesday. So this would have been Tuesday's lesson. And then the second part of this will be Wednesday's lesson. So I think I was going to just let this video keep going, but it's going to end up being really long. So I'm going to stop right here and upload this one as part 1, and then I'll come back and do a second one for part 2. So if you only needed part 1, then you're done at this point. But if you missed both days, both Tuesday and Wednesday, you'll need both parts of this. And so part 2 will be coming up in just a minute. Have a beautiful day.